Hello and welcome. My name is Elisabeth Skura and I'm one of the editors at Packaging Europe. Today I'm excited to introduce a special event with Styrenics Circular Solutions, the value chain initiative to increase the circularity of styrenic polymers. For those of you who are unfamiliar with Packaging Europe, we are the leading intelligence resource for European packaging professionals. Via our magazine and website, we deliver daily news content, authoritative comment and analysis, case studies, and high-profile interviews with leading industry players. So today we will delve deep into the circular power of Styrenics and get answers to questions such as how can circular polystyrene best meet the growing demand for high-quality recyclates suitable for food contact applications? What are the achievements so far in fulfilling the intrinsic circularity of Styrenics, and what are the milestones? Which environmental footprint of the different polystyrene recycling technologies can be expected? And also, how does recycled polystyrene compare with virgin polystyrene in the production process of food packaging? With that, I'd like to hand over to Chrissy Schönfelder, Chair of Advocacy and Communications at Styrenics Circular Solutions, who will be your moderator today. So yes, over to you, Chrissy, and enjoy the event, everybody. Thank you.
Thank you so much, Elizabeth. Thank you for the introduction, and also thank you to Packaging Europe for co-hosting the event with us. Good morning to all, and a very warm welcome to our online event. I'm Chrissy Schönfelder at Styrenics Circular Solutions, and I'm happy to be your moderator for today. Now, SES is at a point where we have significant updates to share, and this would certainly merit a larger face-to-face meeting. Given the circumstances, we are delighted that you could, and that so many of you could join us today. As a matter of fact, I've just gotten the numbers. We have just over 830 registrations for this event, 830, so that is a brilliant turnout, and I'm just very glad to see the huge interest for circular styrenics. For those that are joining us for the first time, SES is the value chain organization that intends to transform the styrenic sector and realize a circular economy for styrenic plastics. And here you see the mission of SES, and the mission is precisely, well, with the entire value chain, SES aims to deliver upon the unique circularity of Styrenics. You will hear more today about that, and also where we stand with our innovative technologies that allow us to recycle Styrenics back into high-value solutions, even for food contact. And last but not least, SES aims to create a market pull with all of you here towards our plastic to plastics recycling. So, and with the next slide, okay, here we go. Here we go. We have, how do we turn now this, this unique circularity potential into reality? Here you see the team that we have gathered for you today. And I'm just delighted to be joined by the team. I lead you through. This is Jens Kathmann, Hermann van Roost, and Norbert Niessner, all three of them representing SES here today. Regino Weber from Neue Materialien Bayreuth, and Anabela Ferreira from Intraplás, Iain Sturges from COEXPAN, and Tobias Strasser from Greiner Packaging. And furthermore, we have also a special guest for you. We are delighted to be joined by Paolo Sandri, Policy Officer, DG Growth from the Commission. They all are contributing to a quite packed agenda for today, with advances in food contact recycling, focus on food contact recycling, both from mechanical and depolymerization, an update on life cycle analysis for recycled polystyrene, and in addition, we will hear from our converters how recycled polystyrene behaves in their existing plants. And in keeping best for last, Paolo will then elevate the picture for us to a circular economy for all plastics. So before we get started, I would like to make a couple of housekeeping remarks. First of all, we will hear from each of these presenters in turn, and then later on we will have a joint Q&A session for all of them. And we will have the opportunity to direct questions to them individually or also to get several viewpoints on a specific topic. Some participants have already sent in questions in advance to this event. They've been noted, but it's not too late for you to also send in your questions throughout the event as we go along. And we do want to hear from you. So please take advantage of that. Now, how can you do that? You see to the right-hand side of your screen, you see a panel where you can type your question. When you do so, I'd just like to ask you to be short and to the point. And we on our side will try and do our best to answer as many questions as possible throughout the event. And as I say, it is a packed agenda. So I would like to turn directly to Jens. Let me advance that slide. Jens Kathmann, Secretary General of SCS. Good morning, Jens.
Good morning, Chrissy.
Good morning. Jens, we've heard a lot about polystyrene, that they have an intrinsic capacity for circularity. Set the frame for us. Where exactly are we with true circularity, food contact with Styrenics? Where are we with turning that into reality? Over to you.
Perfect, good. Thanks for that. The short answer, of course, would be we are on target or right on target. But this is true and still does not tell it all, because we have set ourselves very ambitious targets. And I would say actually we are even on a fast track of making this enormous circularity potential of PS a reality. And we ask sometimes even ourselves, why is it that fast? What are key drivers? And one is in your question, it's the intrinsic capability of polystyrene. So Styrenics are designed by the nature for recycling. This helps a lot, boosting this capacity. And one other topic I like to mention is SCS as the association embedding both producers and the Styrenics value chain together. So this combined force and intelligence even allowed us to surpass as we successfully entered the holy grail of food contact packaging, which is part and topic of our event today. And therefore we are very much beyond already the if and how. It's now on timing, when and what, and product recycling capacity in terms of volumes. Another burning question, I trust.
Excellent. Thank you, Jens. And let us know, we have it here on the screen, how does this circularity capacity tie into the benefits of polystyrene throughout polystyrene's life cycle?
Yeah, to start basically, of course, with the circle which we see here, and that it's somewhat familiar, but it's also new, in particular on RPS, recycled polystyrene. If you look at the center, of course, it tells that we have our 3 technologies, all for food contact applications in well and good underway. Basically, also, if you look then at the traditional production coming as first in the circle, you see it's becoming part of this, let's say, virgin production, which we all know and which we all like that much. And therefore, especially the depolymerization and the dissolution add on and contribute, and it's less than replacement, but add on. If you look at the mechanical recycling, you see from the arrows, it creates a bit of a shortcut. Yeah, you somewhat bypass positively the traditional production. And thus summarizing the 3 technologies, I think the great thing here, mentioning food contact, they give a lot of freedom of choice to the market. Time to market is possible on high efficiency levels and high purification food contact. I mentioned that it's more coming during this event. I don't want to jump too fast now. Moving then basically to the next one, very important and also part here of our discussions are the converters. You will learn, of course, from the converters that RPS, especially on the mechanical recycling and the timing, represents a drop-in solution. Yeah, there is no need for invest new equipment. It's really able to replace virgin with RPS. That is really great news. This drop-in, of course, has more other characteristics also for the value chain. So basically from the existing technology, and to most of you, FFS, form, fill and seal means something. It has a lot of additional benefits. And it builds on what we see in the virgin. You have an improved and very good productivity in the extrusion process. We learn later also on energy consumption, CO2 emissions versus our peers, versus alternative polymers, and the cost effectiveness of the material, of course, I think is not in any dispute from all the properties I just mentioned and more. And this, of course, looking at polystyrene opens also the stage for design for recycling. So in RPS, even mono PS packaging is possible. Even it's possible, and some of you might see in some press releases, with a packaging body, a lid, and a sleeve made out of 100% PS, and also to the extent recycled content RPS. So this is really great. This freedom of design is one key issue. Also, if you look at the future challenges, but also, let's say, to position RPS right in the common area and the, let's say, upper league of food contact materials, even in multiple recycling. And this is from this angle with having no limitations even on color. But again, I jump a bit ahead what you hear later, giving so much advantages. And last but not least, looking at PS applications, really already today in the virgin, but also in the recycling sector, having a low complexity as a single layer product. Of course, this is highly beneficial for future, let's say, requirements like the standardization process, quality of recyclates, recycled content, or what is coming onto us. So we are well set for that. That's good news. Moving and of course to important value chain stakeholders, brand owners, and I'm sure some also attending this event today, and for good reason, and of course it's good news also for our connectivity in the value chain. This 100% food grade RPS, of course, we have to see it's of high concern, but of course we have to fulfill that of consumer safety. This loops possible, I mentioned, we have to make sure, but we are on good track on that, having no degradation of materials. And again, I mentioned this already for the converters, there's lots of flexibility in the percentage of recycled content. Unlimited design possibilities, I would mention also here, and the use of RPS in all original packaging, and therefore, of course, also building on the benefits I mentioned already in the production and mechanical recycling. Just an example, of course, a contribution to future requirements with regard to CO2, climate neutrality, a reduction of the environmental footprint. Again, I jump. There will be a presentation by Regino Weber from Neue Materialien Bayreuth, but it offers additional, let's say, opportunities. The distribution to come next, I mean, I jump, it's more or less similar as for the virgin, but of course all the advantages also count here. Looking at the retailers and similar to the comments on the brand owners I mentioned, of course, this long shelf life, which we have and can maintain and also build up with RPS from its inertness. It's a striking argument, especially for the dairy product stability, looking at barrier properties, yeah, prevention of food waste, looking at long shelf lives, but also need for packaging, important arguments for the retailers. And therefore also same as for the brand owners, and in general, this what we do with RPS is also representing such an enabling function to achieve sustainability targets, energy savings, and contributions to a more sustainable environment all across the life cycle. Yeah, and last but not least, to say so, but most important also in all this circle inclusion, of course, the end consumer, and it may be not clearly seen from the picture in the background, but you see somewhat a shelf and a hand and an arm reaching out to dairy packaging. The end consumer, of course, can only benefit from those closed loops and 100% circularity. We have, of course, sustained customer experience. You will see it later. This multi-pack yogurt cups and the clicking, but also means the safety of transportation also in the shelf is highly important. And then, of course, it also represents, once we get further, a convenient return to recycling because we then can use it also in selective collection and sorting, which we, of course, strongly fight for, and also even looking forward on deposit return systems. So having said all that, I think striking benefits, and I tried to my colleagues here not to jump that much, but I think also it was exciting enough to open the scene to what is coming. We are in good shape. We are on target to start and end with a question and more to come, not only in the event, but also in course of developments towards 21 and 22. This is from my side, Chrissy.
Excellent. Thank you so much, Jens, for bringing for us together the known benefits of polystyrene that we know from virgin polystyrene, also with the circular solution that polystyrene is about to bring. And with that, I would like to welcome Hermann van Roost, General Manager, Feedstock and Mechanical Recycling at SCS. Good morning, Hermann. Hermann, we have seen tremendous progress with mechanical recycling up to the level of achieving food contact standards. Do give us a full picture where we stand currently and what it means for our value chain. Take it away, Hermann.
Thank you very much, Chrissy. And indeed, I'm very happy to confirm that we are really on track with the ambition that we expressed a couple of years ago. As a matter of fact, we should not forget where we come from. As late as only 2018, the common industry belief was even that polystyrene objects could not be sorted from the different types of polystyrene. So we established there the sortability, and we were really surprised to be helped by polystyrene that it is so easily sortable. Last year, we could announce the production of high purity mechanical recyclate, and also there that was a surprise. And this year we continued the pioneering track to, let's say, what is the highest possible, and that is technical food contact suitability. So this is indeed great. And as a matter of fact, if you look at polystyrene packaging, what the most striking thing is that it is overwhelmingly food contact. You can see, of course, different forms. Sometimes it's rigid, sometimes it is foamed. But what we have found is that all these types can be perfectly sorted from each other. And so that was done in detailed sorting tests with our SCS member Tomra. And we can distinguish the GPPS from the EPS, from XPS. HIPs can even be distinguished by a percentage of rubber. It is really amazing. We didn't expect that ourselves. So that is an excellent basis for the production of recyclate with very precise properties. Now, we expressed the ambition to close the loop from yogurt pot to yogurt pot. And if you want to develop a good feedstock for dairy, it's obvious that we want to focus on white HIPs, right? Not because the colored HIPs cannot be recycled. On the contrary, PS has excellent outlets for colored recyclate. But for returning to dairy, what you really want is white HIPs. And starting from sorted packaging waste, actually, we developed this process. White HIPS appears to be the largest fraction in all countries. The percentage can differ. In this fraction of white HIPS, what you find already is that there is more than 97% food contact. And then what we did further is, okay, we can do either by hand picking. We analyzed what is then the rest, and that was then used for learning of the near machines, and so by doing this, we can go to more than 99% food contact, either by hand picking, like happens in many other recycling process, or by having another near step with the learning from there. So there is two ways to go to an extremely high amount of food contact in the feedstock. Then our recycling process, actually, it was completely inspired by the mechanical recycling process that was developed for PET. But we improved it because, let's say, the contamination and the typical design features of yogurt pots are different. And so the result is a very powerful process that is really optimized to the typical yogurt pot design and the residue. And it removes basically all aluminum, paper, foils, organics, and even printing inks. So in developing that process, we also learned how to control the washing process, because it's a tricky part. And basically what we do is you take the freshly washed recyclate and you wash it again in more severe conditions. And then you analyze the water quality. And it can be a big difference between existing recycling processes and washing processes, actually. And here, this is the last missing mile, actually, super cleaning and challenge testing. And here again, we were helped a lot by the outstanding quality of PS. It has a low diffusion characteristics similar to PET, actually. That makes it very suitable to achieving food contact status because it doesn't behave like a sponge. The surface is, the matrix of the polymer is really closed, and it doesn't absorb a lot of contaminants. And for the things that might be in the polymer, this property prevents it from migrating out of the polymer into the food. So this is, it's a key characteristic for suitability for food contact. Then we had to apply challenge testing technology for deep cleaning in order to correspond to the very high EFSA requirements. And for that, we were very proud. We are very proud today to announce that last month we achieved a success with the INEOS technology. And actually, the INEOS technology is already a mature industrial PS reference. It is already used in Japan since 10 years, where 70% of all Japanese PS trays actually are recycled in this technology, and it happens under an FDA approval. So what we will do now is, based on our test results, use this as a first for a first petition of EFSA in order to obtain authorization for food contact and in the EU. And one very good news that I can already announce, and that's a prime announcement actually, there is very promising results with a second technology that of which you will hear in the next period. But this is definitely in our pipeline, and so it means that we are working on widening the range of technologies for future investors. Now, the recyclate produced this way was on top used to to make really filled yogurt pots by the 3 converters that are members of SCS, COEXPAN, Intraplás, and Greiner Packaging. And you will hear it from them in a few minutes, but the results were great. There was no observed degradation of the polymer. The purity was very good. Nothing to comment, no comments or no remarks on the smell or taste of the yogurt. And it's really, let's say, also in the processing, our PS behaves like virgin PS. So that's the best that we could expect. And last but not least, we have prepared an industrial blueprint for interested investors. Many parties have been watching what we are doing, and many parties have been waiting for the demonstration of technical food contact suitability. So what I expect is here an acceleration of industrial initiatives, and what we offer to these interested parties is a blueprint with flexible plans so that they can adapt the percentage of PS to the availability of feedstock and to the demand. Yeah? It can be used for PS but also for foamed PS. Yeah. Typically, in order to be competitive, what we propose is something like 50,000 tons per year sorted feedstock input, and that will produce 33,000 tons per year recyclate production. And it is the capex is like 40 million. It's you see the typical layout, but in this way it is really cost competitive versus virgin PS. So it's from all aspects it's an interesting investment. And in order to support this kind of investments, we are also ready with the members of SCS to support testing of process and with a semi-industrial line that is now starting up. So that's the work. I would say we are really ready for the next steps.
Excellent, Herman. Thank you so much, and great to hear about the positive challenge test, and as you say, the last missing mile for mechanically recycled polystyrene. Now, on your way to food contact, what would you summarize are the key hurdles that you've already taken, and what are the challenges that are still ahead?
Well, you have seen a lot of hurdles that were taken, and we were all the time helped by the properties of PS, sometimes to our own surprise. And the next challenges are also opportunities, because we are going to extend further the range of available technologies for supercleaning in order to offer to investors the same range of choices as what they can find today in PET recycling. That is one thing. We are also going to extend the food contact authorization from rigid PS to the foamed PS, because our process works also for the foamed PS. We've done preliminary testing, but we kept our focus for the moment on the rigid. And then the challenge will be, and opportunity will also be, to offer to the waste and recycling sector an excellent way to expand their production of sorted plastics for recycling. Because today they don't have, or they have very little incentive to optimize sorting out of PS, and creating that market pool is really what we were aiming for. So this is our program for the next the next year.
Excellent. Thank you so much. Thanks a lot, Herman, for that. And with this, I would like to bring in Norbert Niessner. If you can turn on your camera for us, Norbert, thank you so much. Great, there he is. Norbert Niessner is Shared Technologies at SCS. And let me put to you, as part of the SCS portfolio, besides mechanical recycling, we have the chemical recycling technology, depolymerization, which is already quite developed. Norbert, in which way is depolymerization and polystyrene a perfect marriage? Take it away with that, Norbert.
Absolutely. Thank you very much, Chrissy, for your kind introduction, and happy to be in this circle of speakers. Let me take you to the first slide and add and echo what Herman said in his last passage of his presentation. We all know and we all knew about the properties of polystyrene, but we redetected them again in a very positive sense when we developed recycling concepts. And polystyrene, just to recap, is stable. You can say that we do not sacrifice properties when we recycle polystyrene. Polystyrene is well proven over decades actually in food contact, and therefore nearly infinite recycling cycles are possible actually. And that has to do with the sorting, which is written on the right page. You have already seen that polystyrene is somewhat excellent for sorting. So the detection technology near infrared is perfectly suited to sort out polystyrene from other plastics, and therefore that's a prerequisite for a successful recycling over more or less endless cycles. And on the right side, on the left side, you see the recycle circle. This means that polystyrene is actually, due to its intrinsic properties, made for recycling. And we heard about the mechanical recycling, but we will now hear about the depolymerization, and I will show you why polystyrene is unique here as well. In order to get an overview, please have a look at the portfolio of polystyrene plastic to plastic recycling technologies. So basically, we heard from Herman already that if we have sorted and highly sorted material, we can, with this mechanical recycling, including a certain treatment, we can recap basically, or we can reproduce food grade quality. And depending on the quality, which you see on the right side, there are different solutions out there. So for mixed plastics, this is I would say a global initiative by many big chemical companies to use mixed plastics, which is today an important fraction of the recycling and sorting process, to use them into feedstock recycling, right? So that means also thorough purification, elimination of catalyst, poisons, and heating about 600 centigrades. So something which is done already, yeah, in the industry, which is done over decades already. And this route provides the access of small molecules via this high temperature treatment of mixed plastics, including polystyrene, or also, as the name says, other plastics as well. Then if we boil down to polystyrene from mixed plastics, then we have the depolymerization. And here the clue is really that polystyrene is one of the few polymers having a benign so-called sealing temperature. What does that mean? It means that at a temperature of slightly below 400 centigrades, we can depolymerize polystyrene straight into styrene. Of course, depending on the conditions, we create byproducts. That's clear. We have to to clean that up, to distill it. But basically then we can create exactly the same, let's say, purity as if we would, let's say, buy on the market fossil-based styrene. So we have demonstrated that, and therefore that is a really interesting route for polymers like polystyrene, which have this sealing temperature in a benign range. And then we also have other properties like or other recycling schemes. Food contact we had already, that's in the middle. Dissolution is something we are looking into as well as a working group within SCS. Dissolution is of particular interest for let's say well sorted waste which is purified without disintegrating the polymer. That means we purify it by dissoluting or by dissolving it into a solvent and by reprecipitating it. And therefore, this cleaning step provides another route towards a high quality material. And yeah, last but not least, needless to say that let's say the routes that we have investigated seem to show low energy and low CO2 footprint. We will hear from Regino Weber a bit more about that, but we are looking into that as well. And therefore, you see here more or less a holistic picture of, let's say, the technology pool that opens up today for the future. So there's no one size fits all. We have many options addressing the different qualities of the sorted or unsorted waste, and that gives especially polystyrene a bright future. So the addressing the what Chrissy mentioned, the perfect marriage of technology and material. Why is that in the case of polystyrene? As I mentioned, it's given by nature that polystyrene can most easily be reversed into its original monomer styrene, of course with byproducts, and they can be purified. That means we have one monomer. It's efficient. We have high yields. The monomer is a liquid. It can be purified by distillation. The depolymerization works with post-consumer waste, post-commercial waste, post-industrial waste, and it is pretty stable. It is pretty benign and robust versus certain impurities. So, for example, we have tested polyolefin impurities, PE and PP, up to 10 or even higher than 10%. No problem. Yeah, process is robust. And even impurities where we say, yeah, that could be a challenge, still pretty robust, up to 1% of impurities. So a process that proposes or that promises a low level of complexity and let's say a robust behavior regarding lot-to-lot inconsistencies, which you will have when you collect recycled materials. And here again, a bit for the chemistry aficionados amongst you. So it's the polystyrene depolymerization works like opening a zipper. You have the chain, which is the zipper, and you open it up by thermal treatment, by heat, and you depolymerize it into styrene, mainly, yeah. And this styrene, after purification, is then used back into polymerization. So a true recycling. Temperatures, as I mentioned, starts at about 300 centigrades, process temperatures at about 500. So pretty moderate, easy in principle to control by given technological means. Picking up the slides you have seen before, by this unique process, we will return to the styrene monomer with high yield and purity. So today we are talking about, depending on the process, about 70% up to 80-ish are in view. And I can tell you as researcher, this will not be the end, yeah, but we might come to that later. The recycled styrene has same quality as virgin styrene. That means we have high requirements on virgin styrene. The ASTM standard, for example, for virgin styrene says 99.8 purity. And I can confirm we have received that after our processes, also our distillation processes. That means same quality, and we were able to create polystyrene out of it. So we put it to the test. It polymerizes to polystyrene, and that can be done a few times. Not only once, twice, 3 times. So over and over again. Of course, it's not a natural process with 100.0%, but we are, as I mentioned, working on this yield question. The depolymerization results, as I mentioned, we can add that based on this high quality, we don't see in the moment any limitations in applications, because let's say the old perception, let's say former time perception on classical, let's say recycling is it's more or less a downcycling. So you create whatever bottles and then maybe fibers, and then comes, well, you go a bit down. But this is here we don't see that case. We see no limitations. We see that due to the high purity, we fulfill or we are going to fulfill the consumer safety regulations, and in the moment we don't see any difference in the purification versus the fossil-based styrene. And maybe we can mention that last year there was an ISIS award for INEOS Styrolution on having firstly demonstrated to repolymerize styrene into polystyrene. And I might disclose today this did not proceed only by radical polymerization, which is the industrial standard, but also by anionic polymerization, which requires a super high purity. So also that worked. That means all indications show we are on the right path towards virgin-like recycled styrene quality. Yeah. Then maybe the last point you might ask about the technological readiness level of the depolymerization. I think this is, despite the fact that we are really having here a new technology, I think we can check this box. So because several companies like Agilix and Pyrowave have processes on the market for polystyrene depolymerization. There are plants in operation in the US, and there were several announcements. For example, one of INEOS Styrolution and Transir to advance plans to build such a depolymerization plant in France as well, and that is planned to be fully operational by 2023. So this is just an example showing you that this is a very, very dynamic field, and plastic-to-plastic depolymerization capacity implementation is underway.
Thank you.
So that was my contribution. Thanks, and open for questions.
Thank you, Norbert. I do have a question for you. I mean, you have now shown us that, or made a very strong case that depolymerization and polystyrene is particularly advantageous for depolymerization, as it can be unzipped back to the original form, and from there it makes recycled polystyrene from depolymerization a great option to go to food contact. All right. What do you say to those that have doubts about chemical recycling in general? Yeah, what do you say from the depolymerization perspective? You said technological readiness level, you've already refuted doubts, we are there. But what about economic viability for depolymerization?
Yeah, thanks, Chrissy. I think this is a very valid question, but to be utmostly open here, I personally believe, and I think I speak for the whole working group, that this polymerization, despite being implemented in the moment in the market, has a great perspective, not only ecologically but also economically. And why is that? Because we are speaking, as you have heard, about 70 to 80% yield, which we receive in 2 days operations on lab plant scale. And let's say I know from own work that this is not the end. And clearly, I don't think I spread secrets now. Clearly, the target is to go up this ladder. And the option is definitely there. The more you control the reaction conditions, like residence time, like temperature, especially, plus in combination with the feedstock, the better you go up in that way. And there is in the moment, no limit inside. But imagine we cross maybe the 90% range. Then the question is, do we need a very, a detailed separation distillation process, or can we make it easy? One easy step, or maybe in future, no separation, no distillation at all. So the development clearly goes into reducing complexity, reducing the cost for purification. And then if you have that, then you can almost calculate yourself. You take the price of the raw material, you take the typical utility cost of a plant. Every one of us knows this is pretty limited. And then you have the cash cost of the process, and that becomes very, very interesting. So I think we are on a competitive way, even despite the fact that we have just started. I think we are, let's say, further than many of us think. So I'm very positive in that.
Excellent. So that means a lot of upside potential, or even further upside potential to look up to with the scaling up. Excellent. Thank you so much, Norbert. Very insightful. And that brings me now over to Regino Weber, to our next speaker, who is Research Associate Division Polymers at Neue Materialien Bayreuth. Good morning, Regino.
Good morning, Chrissy.
Regino, the environmental impact of products and recycling processes is obviously of utmost importance to all of our stakeholders here at in the webinar. For that reason, SCS has started a life cycle assessment for all of the technologies that SCS is looking at, mechanical recycling, depolymerization, and dissolution. And while the LCA analysis is still in progress, Regino, what can you tell us about scope and some first insights?
Yeah,
over to you,
I will present them now. Thank you, Chrissy, for the kind introduction. I would like to welcome everyone. My name is Regino Weber, and I will present you some first insights into a comprehensive life cycle analysis for polystyrene, especially for recycling processes. So the first point I want to mention is the importance of life cycle assessment itself. Because when you, for example, taking recycling technologies as an example, it is clear that they are inevitable for a circular economy. But the question there is if the processes, they also generate emissions. And so the question is if they are really environmentally sustainable. And also the question would be how they do compare to currently used end-of-life treatment options. And to answer this, a tool is needed to evaluate the environmental impacts of products and also to generate comparable values out of this. And here, life cycle assessment comes into place. As it is, it allows an in-depth analysis of a product's environmental impact along its whole life cycle, as seen on the right side. And so, together with Styrenics Circular Solutions, we are developing a comprehensive life cycle assessment for different recycling routes for polystyrene. And this is to work out possible benefits which are occurring compared to the current state of waste treatment. So for every life cycle assessment, it is very important to define the goal and scope of the study itself. And so I will go a little more in detail into that here. So the definition of the goal here, it is, we want to environmental assessment, do an environmental assessment of different recycling processes for polystyrene, and also do a comparison to current end-of-life options. And here it is important the evaluation of potential ecological benefits offered by recycling processes here. And also we want to generate a comprehensive and consistent database for the life cycle assessment of these processes. The scope of the study is the development of a comparative LCA for different end-of-life treatment options for polystyrene. In particular, we will take a look at the mechanical recycling, the depolymerization process, dissolution process, and also we will compare it with incineration. The whole study will be done according to the ISO standard 14040 and 14044, which sets the boundaries and the framework for conducting such studies. Also, the whole study will be based on calculated or measured data. And in the end, when the report is finished, the whole study will be peer-reviewed by independent experts to verify the results of the study. So also for every life cycle assessment, it's important to set the system boundaries so that you know which processes are to be included there and also what is not to be included. And here with this picture, I want to show that we are taking an approach of a cradle to gate study. You see in the schematic here, we start with the end consumer waste, which is collected and sorted, and then put into the different recycling processes or end-of-life treatment options like incineration, then depolymerization, dissolution, and mechanical recycling. So as I said, it is a cradle-to-gate approach here. Also, we agreed on to examine two different scenarios of these included processes. And you can see then here, we want to consider the treatment of 1 ton of PS in mixed plastic waste on the one hand. You can treat it as with recycling or also with incineration. And on the other hand, we want to take a look at the production of 1 ton of polystyrene pellets. And these can be done through a fossil feedstock, and also for the recycling process, it would be a waste feedstock. So to go a little more in detail about the end-of-life treatments, we will take a look at. I will shortly explain this with this schematic. And all the different scenarios have in common the input we are taking. This is the polystyrene and mixed plastic packaging waste. In particular, this waste fraction is from municipal packaging waste that contains 4% of polystyrene content in it. And with that, we are going into the different processes. The mechanical recycling, where it was also talked about earlier. The material is sorted and washed, etc. And then in the end, you get out recycled polystyrene pellets again, and these pellets can substitute virgin material. For the dissolution as a second process, the material will be dissolved, then cleaned up, filtered, etc., and then dissipated. And in the end, you also get out recycled material, which then also can substitute virgin material again. And here, I want to thank Polystyrene for providing the process data we are using for the LCA. Then we have the depolymerization process. There, the material is depolymerized into styrene. And then to have a fair comparison in the end, we will also include the polymerization step again to have, in the end again, recycled granules, which then substitute virgin material. The process data for that stems from Agilex, and thank you for that, that you're cooperating with us here. And the last process we're taking a look at is the incineration process. Here the material gets burned, but also besides that, incineration generates electricity and also heat, which can be valorized in the end. So now I will come to some preliminary results and first finding of the LCA we have done till now. And just to inform you, all the results that I will show here are from mechanical recycling, and that compared to incineration and also fossil-based material. So here you see the first results. I will explain the graph on the left side a little bit. It shows the relative global warming potential. So sort of say the CO2 emissions of the processes. Here in comparison, there is the mechanical recycling and the incineration process. The bars that are going above 0 represent the CO2 emissions, and everything below 0 represent credits given for valorizable outputs of the process. So you can see here as example for the incineration, we have the CO2 emissions, but also, as I told earlier, heat and electricity are generated there, and so credit can be given, and in the end you get out the total value represented by the blue dot here, and this blue dot in this comparison is set for the incineration to 100%, and so comparing it to mechanical recycling, for the treatment of 1 ton of polystyrene in municipal packaging waste, you can see that the mechanical recycling shows can save up to over 50% of the CO2 emissions compared to the same amount in incineration. And this leads to the result that mechanical recycling is an ecologically viable option for the end-of-life treatment of polystyrene. In the second scenario, as I told earlier, we took a look at the production of 1 ton of polystyrene granules. Also here is the comparison shown for the relative global warming potential. So here, for the virgin material set to 100%, that even if you compare the recycled material, the granules, to new granules, virgin granules from fossil feedstock, you can save up to 37% of the CO2 emissions caused by that. So the next slide shows the combination of the both presented scenarios, and so we get the following results we have here because we combined these because when you use waste as a feedstock, incineration is avoided, but also, if you don't incinerate the material, when you incinerate it, it is just burned. But when you don't incinerate it, it can also replace virgin material. So I think, it is viable to combine these two values. And if you take a look at that graph on the left side here on emissions for incineration and also for material substitution are combined on the left side and the right side. And when you compare it to mechanical recycling, you can save up to 75% of the CO2 emissions. So when I would go on the next slide here, I will summarize my short presentation, and this is, we are doing a comprehensive life cycle assessment for different end-of-life options for polystyrene with a cradle-to-gate approach. We're doing a comparison of the environmental impacts of each waste treatment route, and the study is done according to ISO standard 14040 and 14044 and will be peer reviewed in the end. And the first findings we had confirmed that mechanical recycling is an ecologically viable option for the treatment of plastic waste. Also, mechanical recycling emits significantly less CO2 compared to incineration, and mechanical recycled granules show lower CO2 emissions compared to virgin material. So last but not least, I want to give a short outlook on what the next steps are into the life cycle assessment. So we will also do life cycle assessment for depolymerization process and also for the dissolution process. Then when we have done all this, we will all evaluate all the results and prepare a final report. And also when this is done, we will do a critical review through a independent review panel. And with that, I want to thank you all for your attention, and I will hand over back to Chrissy.
Thank you. So first of all, thank you, Regino. It sounds to us that this will be a very comprehensive study once it is finalized. Let me ask a couple of questions. How do you deal in your LCA with the byproducts that you're getting? Are they being fed back into the LCA calculation as a source of energy, for example, or how do you deal with them?
Yeah, that's a good question. I will try to answer this like that. Wherever possible in an LCA, we are using system expansion or allocations to deal with these side products. And for example, for mechanical recycling, there are often some residuals from the washing and also the sorting steps. And here, they are typically incinerated, and these incineration processes we are also taking into account, but we agreed on that we will all only take the emissions from these processes, incineration processes, into account, but we won't give a credit for the heat and electricity created from the incineration of these byproducts. So I think we have a really conservative approach here, as we don't credit for these.
All right, okay. And another question regarding mechanical recycling. Can we assume that the LCA analysis for mechanical recycling for other polymers are mostly in the same range?
So I would like to answer this as follows. We have the when you take an LCA study for recycling, for example, there's typically a quality factor involved for when you have degradation into the of the polymers while the recycling processes, and these is considered with this quality factor I mentioned. And as we seen earlier in this session, for mechanical recycling of polystyrene, the results show that is can be recycled with nearly no degradation of the properties, and so this the quality is no concern there. But this isn't the case with some other polymers, as they show some worse quality when they are mechanical recycled. And so the quality factor is a consideration there. And for that, I would assume that polystyrene in the end will have a lower, after mechanical recycling, will have a lower environmental footprint compared to some other polymers. I hope I could answer your question.
So that means you're basically underlining the statement that Herman has made earlier, that one of the intrinsic qualities of polystyrene is that it does not degrade in mechanical recycling, nor then in extrusion and thermoforming. Yeah, and that is what you also see here in the LCA analysis in comparison with other polymers. Yeah,
that's exactly it.
All right, thank you so much, Regino. Thanks a lot for that. And I would now like to move on to the perspective of the converters. And for this, we are joined, and I would like to ask you to turn on your cameras. We are joined by 3 leading converters for the dairy industry. We have here with us, and maybe you can wave or not so that people see you. I start with ladies first. Anabela Ferreira, co-owner and executive board member Intraplás. Iain Sturges, chief procurement officer at COEXPAN. And Tobias Strasser, managing director at Greiner Packaging. Great. Thank you for joining us here. Now, we know however much we do tests, challenge tests, and our studies, I guess the real test that recycled polystyrene has to pass is really what you, the converters, make of our recyclate, and also what it holds then for the brand owner at the end of the day. So let me put this question over to you and start directly with Anabela. Anabela, you have used mechanically recycled polystyrene in your existing production process. Yeah. How did it work? How did it compare against virgin polystyrene? Over to you. What were the parameters that you've noticed?
Bom dia, warm bom dia from Portugal. Before of all, I would like to, in behalf of Intraplás team, to say thank you to be able to be here and to share the great news that we have for our brand owners, clients, suppliers, all the entire value chain that is here with us. Going back to your question, Intraplás did run tests to compare the behavior between mechanic recycled polystyrene with virgin polystyrene. We divide the analysis in 2 ways: the industrial trials, and then the yogurt cup itself. So we run the test in our extrusion lines and our thermoform lines, and the conclusions are very simple, like you were saying before. Same results, no adjustment in our equipment, and the same productivity of the machines. Then, in our research and development center, which we have a form and fill and seal machine, or FFS machine, and which we can do a dry test and to do the multi-pack yogurt, and again the same results. The equipment was running in the same way, same heating requirements, the same cutting tools, and the same productivity. Now, going back to the cup itself, the products, let me show you. Of course, this is a web, but I can assess and ensure that it's done with recycled polystyrene. We have the preforms and we have the multi-cup. So going back to the product, we have the same look, the same touch. We got, very important, the same resistance to vertical compression, which means that for our clients, when they are transporting the yogurt already fill-in, they will not have any change in the logistic process. Then, very, very important for those and for our clients that are listening to us, in terms of multi-pack, we have that tricky problem about the snappability and the bane behavior, and we very happily can say that we got the same snappability. If you may, I will try to do it here in front of all of you. And I'm sorry, I have to do that because this is crucial, and Iain and Tobias can say the same. So we got it, we did it. No changing in cutting tools, no adjustment in the cutting tools. So I'm sure that the clients will be very, very happy. Finally, so what can I say? Going back to what already I have said, RPS is the easiest to recycle. It has lowest complexity, and I'm very positive to say that we found finally a sustainable solution that, in terms of converters and in terms of our clients, brand owners, will have the same outcome, and very important, without any investment. we should put our investment in innovation, and we shouldn't be worried now in making adjustments in our equipment, and important for our clients as well.
Thank you, Anabela. Very strong statement. And I see Iain smiling and nodding around the way. Iain, what was your experience? So tell us a little bit about how did recycled polystyrene perform in your plans?
Mute button. So I think everything that Anabela said is very good and extremely exciting. And from a business point of view, the best thing that we can have are options. The more options, the better, as far as we're concerned. And not only does the industry now have a very strong polymer as an option, a viable option moving forwards, within polystyrene we have 3 technologies, which is absolutely unparalleled. And may I say that from a market standpoint, the pull and the interest in recycled polystyrene is absolutely immense. It's unprecedented. And what I'm here to say is that I think that we have actually a new benchmark polymer for the industry. And let's look at the facts and let me run them through you. We here in our Intertech Center in COEXPAN, we've tested all 3 technologies, okay, all 3 technologies. And can I say it's identical to virgin? I would say it's better than virgin, because virgin cannot compete with one single characteristic that RPS has, and that's the R. Everyone wants the sustainable, the recycling element within their production, within their packaging. And recycled polystyrene delivers that in a truly outstanding, unparalleled way. So for us, it's a really, it's a new benchmark for the industry. Let me take you through 4 key critical areas. Quality, we've heard a lot about quality. Quality, there is no mechanical loss. So it's infinitely recyclable, and this high quality means that we actually use less. So if use less material is important to your business, recycled polystyrene is the top option for your business. In terms of productivity, it has unparalleled productivity, mainly driven through this high standard of quality. But in terms of productivity, we can say that it's probably between 20 and up to 30% higher productivity than any alternative that we've managed, okay? In terms of energy consumption, we've heard a little bit about our colleagues talking about energy consumption, between 30 to 50% less than any available alternative. So if CO2 emissions, CO2 footprints is important to your business, this has now become the new benchmark, the new leader as an option for your packaging. And the one that I'm truly excited about is the fact that it's truly circular. Okay, polystyrene is now truly circular. What does that mean? That means that the full population of all applications of any polystyrene product can now be sorted and transformed between one of the 3 technologies. It can be transformed into any product, okay, without any barriers. We know that the bottle-to-bottle system is a circular system, but the bottle-to-yogurt pod system is not a circular system. You'll be taking material from a circular economy and you'll be putting it into a non-circular economy. And that is where polystyrene has a significant advantage, and one that today no other polymer can compete with this, okay? So if I was a legislator, if I was a business owner, if I was innovating and developing new products, you'd probably get your list of paper and you'd have your kind of list of, ingredients to use, your formulas. You'd have your kind of try to avoid guys here at the bottom. You'd kind of have your keep guys in the middle, and right at the top, you'd have your try to use, okay? What you should be looking to use. And polystyrene is now a new leader in this category.
Excellent, Iain. I see your camera is right now frozen. You have made a very strong statement, and as a Chief Procurement Officer, you have basically brought us into polystyrene, recycled polystyrene. But now let's take the perspective a little bit further. Tobias, you've also been using recycled polystyrene in your plants and are in conversations with retailers on the Swiss market, on the Swiss market with Migros. Tell us a little bit about your experience, please.
Yeah, thank you, Chrissy, and thank you that we, as a Greiner Packaging, can be participant of this great event. And let me confirm what Anabela and Iain just said. We have really, with this recycled polystyrene, very nice drop-in solution for the market. We made along the supply chain the same positive experience within the Greiner Packaging as also with one of our famous customers. So that means the filling process at ELSA, a member of the micro industry in Switzerland. So we made some tests together with them along the supply chain, and we went smoothly without any changings of parameters with the polystyrene cups, has passed all the tests along the value chain, such as the sensoric taste, or the shelf life, or logistic tests. So that was really amazing for us, that not even in Greiner Packaging, also at our customer and the supply chain, we have really great results with this drop-in solution with this recycled polystyrene. And the good news are that the retailers and brand owners can use still the advantage of the polystyrene along the supply chain until the customer or the consumer such like the separation ability, as Anabela already shown, but I have to do it the same way. And that's a big advantage of polystyrene, but with a lot of other advantages, we have really no changings along the supply chain.
Excellent. I love to hear that sound.
Let me just, Chrissy, we are reinforcing this snappability because it's crucial. And the clients that are here to us, the tricky question of the beauty of the polystyrene over our multi-pack is the fact that it's snappable. And of course, with RPS, we got the same result, and this is really exciting for us and for our clients, I'm sure, those who are hearing us.
As well as for the end consumers who like to enjoy that yogurt cup. Excellent. So
with safety.
So in essence, you have all worked with mechanically recycled polystyrene. You confirm that it is a drop-in solution in the existing plants. No changes need to be made. The unique benefits of polystyrene are being preserved within the process, and the consumer experience you have shown us so nicely is unchanged in terms of the look and feel. Great. With that, with this super encouraging message from the converters, I would like to go over to Jens, and let's talk about the market pull, Jens, that we have seen here on the side of our converters, and have a look what comes next. If we can have the presentation slides on again for Jens. Super, excellent, wonderful. Jens is already there. Excellent. So Jens, please take us through what are the next milestones, not only in terms of food contact, but also in terms of scaling the capacities for recycling. The floor is yours, and I will drop my camera off.
Thanks first of all, Chrissy, a good introduction, and also listening to what we just heard, this really strong testimonials and coming to what I called in the beginning the fast track. And I think especially if you look, SCS was founded in early 2019, and starting here with those achievements to date, and lots of information was given here from really interesting presentations. We have, of course, what was mentioned here by Anabela, this safety in the food contact, consumer waste, to have it in multiple circles, integrated sorting collection. So we have those studies done, amongst others with Conversio, and the good news here, we have sufficient post-consumer PS in the waste streams. Yeah, to just give you a figure, we have 800,000 tons more than that in food packaging, and unfortunately in this case it goes to incineration, not in the collection and sorting. But again, turning this positive, of course, we have feedstock which is accessible, and I'm coming later why and how we access that. The sortability of materials, and again referring a bit to the converters, you saw those white shiny RPS, of course, is a proven thing. We have underwent a lot of studies supported also by our member Tomra. This really turned out to be really great, and also opens the doors for next activities and other styrenic polymers, be it EPS, XPS, or be it even later styrenic copolymers such as ABS. The mechanical recycling, it was said, excellent. The purity level, also confirmed by challenge test, is great. Another technology, not that much, of course, mentioned today, but coming and shortly coming up, dissolution. Again, we are already, let's say, finalizing challenge tests here. We are in close reach to the food contact suitability, proving that the compliance. I see another EFSA petition process coming early next year, and that really great progress. And I think last but not least, but also amongst the first technologies here where SCS was working on since its beginning, and explained by Norbert also, the depolymerization, even opening more freedom in the waste stream and the waste quality input, but also giving, let's say, a nice in-route into the production of our virgin polymers and blending, and of course also fulfilling here recycling content by styrene oil or styrene purified styrene after distillation. So that's all great news, and it's just hardly telling how busy we are and how busy we were looking in 2020 even, which is almost over. You have heard about that, the successful challenge test, the first. We are going now to EFSA for the petition for the mechanical recycling with the noise technology, but more to come. Basically also this commercialization process, Iain mentions this parallel work we are doing, and again strongly supported, and so many thanks here to the value chain pushing this forward. And it's good news, of course, also talking on EFSA that we don't have to wait for the EFSA petition and approval process, that we of course can go ahead with the ABA structure. And you have learned from Hermann that we have this RPS, which we have seen here demonstrated, using this in the B layer and being then therefore ready to jump on once we have the EFSA, the first EFSA petitions and approvals by that. The mechanical recycling with ABS, of course, is coming up, but again, parallel work in good swing. It will be one of the key topics in 21. So today, maybe not too many ABS producers or customers or converters on. However, we have Elex, we have INEOS Styrolution, Transeo, Versalis, rely on us. We are strongly pushing on that to really in 21 come up with really not only first, but also decent solution to recycle post-consumer ABS in a positive way and commercialize in recycling contents, as you see here, 50–70%. Really good news is to come. We cannot cover it all today, but 2020, lots of groundwork has been done. And I think also the LCA study, as explained by Regino, confirmed, of course, the excellent footprint of our recycling technologies. And listening to Iain, of course, brings us even to a higher level compared to the virgin if you look at CO2 and energy. So we are really in great shape. So what is to come, and what is somewhat the roadmap also? And I think also in the Q&A, I expect a lot of questions with regard to that, but also lifting a bit the secrets here, or also our work streams, which we heavily, of course, push forward. We see in 21 first food contact mechanical recycling plants. I think it came well over, but again, also we have huge confidence that this is going to start in 21. I would not say more, but of course, it will be then happen in the second half of 21. And again, the EFSA, of course, the fact that we can use the RPS already in the ABA. The member optimization of the solution, I mentioned this already, so we expect this really being very concrete, but you have seen surely already first press releases by SCS members and or even third parties by converters. We have polystyrene. We are in close discussion with in the next point here, you see it. Polystyrene also is running already in 2022, at least the first announcement here of 7 kilotons, but really more to come. I like just to say not to underestimate the 7 kilotons. Positively, I think for the value chain is here also that we scale what was mentioned also by Iain according to the needs and give here huge freedom of choice to our value chain to pick between mechanical depolymerization and the dissolution. This is good news. It does not always have to be the big unit to say so. We can scale low, start low, but scale fast then. The commercial depolymerization in France, again, one announcement already. Again here from timing, but also from the fact it's the first announcement. I just like to tease you a bit and raise further expectation. Of course, looking at the volumes we need and the feedstock we have and have to convert into RPS. I think it's very logical, maybe not very serious to talk about this today, but more is to come in this regard. Yeah, and of course all SCS members in the, let's say, petrochemical area are working on this topic. So this is really driving. I come again back on the fast track also. The ABS volumes, as I said, good progress, first announcements by SCS members, INEOS Styrolution, but also others to follow, and also brand owners linking up to that and driving this. And we expect a similar momentum as we have seen it, of course, in the mechanical recycling for the RPS, because the strong need is there. And of course, we will somewhat correspond to this need also, let's say, from the European Commission on recycling rates, that we really drives this on high priority, and Vedas, we are coming in 21 on that. The project pipeline concludes nicely on what I just said, but also in an earlier statement, I said it's not only always polystyrene. We have and did start at one of the very sensitive part, polystyrene, food packaging, of course, also driven by the legislation, regulatory aspects, looking at those national packs. So it was high urgency, and I think we correspond highly effective to this. But we look also at the EPS and XPS. Third of all, in the feedstock manner that we say, okay, we have feedstock there, we have it in the waste, but also to have this plastics to plastics and even from application closed loop for XPS and EPS. Yeah, we have our member Eni Vasalis working on this topic, and I would even say still this year. Some of you might heard about the Revive project already, but also in this year, including Fraunhofer test and EFSA process, there will be news coming up soon. So all for the good, all for the better. The scale up of the implementation, we are working on that. We cannot disclose everything today, but we also will feed regularly what is coming on to the value chain and positive and support and capacities. And of course, last but not least, I mentioned that, but what we do also is absolutely in line as corresponding to the European plastics strategy. And I think this is also another topic. Before I jump again, I would leave it there. Yeah. Thanks, Chrissy. And talking and closing on the European Commission, and we saw already shortly a picture there, as you know, from the agenda, but I like to have a nice transfer to that also, because what we do, and as it was mentioned, it has a huge value for the market, for the value chain, but it also has a huge value for the society. And this is getting more and more important, that you, of course, map yourself and fit in yourself in the regulatory policy environment, but as I said in the beginning, the end user is a bit the yet uncontrolled target. On the other side, the end user is also changing behaviors as far as we can deliver solutions. I think this is a fair statement that we also have a positive potential here. Yeah, and the capacity of polystyrene food grade standards, I think together with brand owners, retailers, but combining all the benefits will send a very strong signal towards that. This multiple recycling, and provided, of course, we have the available bins for collection and bringing the food contact packaging back into the sorting and collection stream, but knowing it's not degrading, it's no limitation and packaging applications. This should really curb and boost and accelerate, let's say, also the sorting activities. Tobias has mentioned that we have a bit of a light tower activity in Switzerland, but saying that best practice and building on those things, we also know in other areas of Europe, these activities are coming up to get this, let's say, society value. We do something good for society, for environment, for the Green Deal. There's a long list of really positive, let's say, achievements and more projects to come. And last but not least, it was mentioned, we don't compare ourselves that much with others. On the other side, bringing now recycled polystyrene and other styrenic polymers to food grade applications, for instance, with a yogurt cup, and you saw the little girl in the beginning, basically a timeless image which we use always and is more and more standing for all what we do. And this little girl, I think, also nicely concludes to the society that we do something good for coming generations, but also I think matter of choices was mentioned. We have an alternative and a second same level with regard to PET in this regard, that it gives the consumer even more freedom to do something positive for sustainability and for the environment. So important for the EU recycling target, I mentioned that, but also we come to more and more high quality recyclates, and therefore correspond nicely to all those demands which I just mentioned. Over and back to you, Chrissy.
Yeah, thank you, Jens. Thanks for the preview of next year and also the year 25, what is to come. And that is actually for me the key word, 25. With that, I would like to announce and welcome Paolo Sandri, Policy Officer at DG GROW, the European Commission. SCS works quite closely with Paolo and DG GROW through our participation at the Circular Plastics Alliance, to which SCS is also a signatory. Great to have you here, Paolo, and thank you for joining us, and over to you, please.
Thank you, Chrissy, first of all, for inviting me here to provide our views on what is happening in the context of recycling from the policy point of view. Just to give you an idea of what my presentation will be about, I have here a short table of contents. I will touch upon the historical origin of the Circular Plastics Alliance. Then I will give a broader overview. I will touch upon the governance of the CPA and what are the next steps and timelines and the deliverables that we foresee for the CPA. As I mentioned, the historical origin of the CPA roots back in 2018, when, with the adoption of the plastic strategy in Annex 3, the European Union called on the industry to come up with voluntary pledges to use more recycled plastics up to the level of 10 million tons every year by 2025. The response from the value chain was very positive, because in few months the value chains organized to come up with 70 pledges for a considerable amount. In fact, we will see here in the next slide that with respect to, if compared to 2016, where the amount of plastics being recycled and actually used in a production line was 3.9 million tons. And now with the pledges we got, with the first 70 pledges, we got to the level of 11 million tons, as you see on the right column, from the recycling side, so the offer of recycled plastics to be put on the market, and from the converting side and brand owners and downstream users, we had the overall pledges amounted to 6.4 million tons a year by 2025. So as you can see in this slide, all the main family of polymers were represented in the pledges. This is a non-exhaustive list. There are more, but these are the main families of polymers. So we considered it to be a successful campaign, although as I showed you in this second slide, from the converting side, from the downstream user side, we fell short of the overall objective of 10 million tons. So we felt at that time, and our political leaders, in particular, our Vice President Kathmann, Vice President Timmermans, and Commissioner Bieńkowska, they felt there was a need for a flagship action with the political support from the institution, and that is why they decided to launch the Circular Plastics Alliance. The Circular Plastics Alliance was intended and is an industry-led initiative. It has been launched by us, the Commission, but it's now completely industry-driven. And it's a cross-value chain initiative with a pragmatic and tangible mission, which is reaching the target of 10 million tons of recycled plastics used every year by 2025. This is, of course, through voluntary action. So we need to bridge that gap from the downstream user side, from 6.4 million tons to 10 million tons a year. The scope of action of the CPA, as it was decided in the first in the inception meetings with the 30 industry associations that were invited to take part to the foundation of the alliance. These 30 associations were representing all the 70 pledgers. So they were invited to start the work, and they collectively decided that there were 5 work streams to be covered: collection and sorting, product design for recycling, recycled content, which is the core work stream, as you can imagine. Then R&D and investment, which also looks at the chemical recycling, and an additional one, which is monitoring system. Setting up a reliable and transparent monitoring system is, of course, strategic for the reliability of this voluntary action. As you can see here, all the aspects of the circular economy, all the principles of the circular economy are covered, except for the reduction target, which is already covered by the legislation. In this case, the Single-Use Plastics Directive. So we deliberately decided to let that principle out of the scope of the CPA. The CPA will have to look at recycling and making use of the recyclates. So on the 20th of September of 2010, after almost 1 year of intensive work with the representatives of the 30, on 20th of September, we had the signing ceremony of the declaration of the Circular Plastics Alliance. It was chaired by Vice President Timmermans, and he is in fact the trade union between the old political mandate of the Commission when the CPA was launched and the current political mandate. So it frames the CPA into the context of the Green Deal and the new Circular Economy Action Plan. So on the governance of the CPA, well, I didn't mention, I should have mentioned in the previous slide that at the signing ceremony, when the CPA was actually finally started, we had 100 signatories of the declaration. Now the members of the CPA who have signed the declaration are 245. And we have a steering committee, which is the main body of governance for the CPA, where all the representatives of all the 245 signatories have a place, have a seat. And we have working groups. The working groups is where the real action and the real decisions are taken. We have working groups for each of the main market segment: packaging, automotive, building and construction, EEE, agriculture. We may have more working groups in the future, depending on how the membership and the representation of different market segments evolves within the CPA. Each working group works under the supervision of a thematic coordinator, and there is one thematic coordinator for each of the work streams. So design for recycling, recycled content, collection and sorting, and R&D. It is essential, the role of the thematic coordinators is essential to ensure that the work of the working groups is coherent with the objectives set out in the high-level declaration. And there is an additional working group which doesn't have anything to do with the market segment, but it's the monitoring working group, and they work specifically on designing a monitoring system, and I will touch upon that later on. So as you see here, there is a table summarizing the list of deliverables for the Alliance. I also put a link so that you will be able to click on the link and have a better overview on the web page of the Alliance. But this is just to give you a general overview, and I will touch upon each of them in the following slides. But so far, the Alliance has been very effective and very efficient in delivering all the tasks it promised, despite the COVID crisis, which was quite of a challenge. But the members were really, and so you were really good in keeping it operational, despite the hurdles that were that came on us at the beginning of this year. On design for recycling, we see there is the Alliance committed to deliver a design for recyclability guidelines. These will be based on a list of 20 priority products that are either low-hanging fruit or strategic products on which design guidelines should be drafted for. And to support the guidelines, the CPA is also working on with the standardization bodies, Senelec, on the standardization needs, because to implement those guidelines, there will be the need of standards at EU level. On the R&D agenda, there will be the identification of 7 strategic R&D needs and plus 12 strategic R&D needs that will be identified. And this list will include the scale up of chemical recycling. I know this is a topic which is particularly important for your polymer. And we are very much hopeful for it's a technology that has a lot of potential to unlock more and better recycling in Europe. The Alliance is very much keen on delivering and on including this work stream within its mandate. On collection and sorting, there will be an upcoming analysis on the untapped potential for collection and sorting, which is it's fundamental for more and better recycling. It's the first step in the value chain of recycling, having more waste separately collected, and it will also help. This is deliverable that will also help with the implementation of legislation, namely the SUP directive. In fact, well, this is actually not probably relevant for polystyrene. This is more for PET, but 77% of separate collection will be mandatory by 2025, and 90% of separate collection by 2030. According to the SUP directive. So this deliverable from the Alliance will be key in also delivering and having a good implementation of the EU legislation. On collection and sorting still, we would need, of course, closer cooperation with public authorities because they have the data, and data on collection and sorting are very relevant to that exercise. And also a closer cooperation with them is also important in order to have a synergic coordination in terms of new public and private investments to develop and to enlarge the capabilities in collection and sorting. And finally, on monitoring, the objective of the monitoring system will be to monitor the evolution of the EU market for recycled plastics, and it will monitor the quantities of recycled plastics in tons and it will look at aggregated figures. So we won't look at figures per company or per product, but it will be an overall figure that includes the whole market. It will be based on 3 pillars. The first pillar will be to monitor the quantity of plastics waste collected and sorted in the EU. The second pillar will be the quantity of recyclates that will be made available on the market by recyclers. And the third and also very important pillar, it will be the monitoring of the volumes of recycled plastics that will actually be used by the downstream users, by the converters. So with this, I would like, of course, to encourage everyone who hasn't yet joined the Alliance to sign the declaration. Everybody is welcome. Of course, I know that the vast majority of you are companies from the polystyrene market, but of course we also welcome academia, public authorities, NGOs, and of course if you are a company, your big role will be to send a pledge. This will be the definition of success of the CPA, having more pledges, having more recycled plastics. That's let's not forget what is the overall objective of this all of this. So with this, I thank you for your attention, and if you have any questions, I will be happy to reply to that.
Excellent. Thank you so much, Paolo. And I do have one right away. You said it yourself, chemical recycling is interesting to our audience and is a technology that we also pursue with depolymerization. You touched upon that very briefly. What role does the Commission foresee for chemical recycling, also in view of your 2025 EU recycling targets?
So first of all, let's clarify that there is no common position yet at the European level on the definition of chemical recycling, and we don't foresee any intention for the time being to revise the definition of recycling in the legislation, so in the Waste Framework Directive. However, this is a personal view that I share with some colleagues. Whatever process that transforms a waste into a new product, and that can be demonstrated that it is the case, qualifies as recycling. So whenever you have as an input plastics waste, as an output either a monomer or a polymer, then it qualifies as recycling, provided that, of course, there is a transparent reporting about the whole process, and that can demonstrate that this is the case. This is, of course, all I can say for the time being, because, as I said, the Commission, there is no internal position yet by the Commission on chemical recycling, but we can, of course, deduce that this will be the case at least until the definition of recycling will be updated. Regarding the role for chemical recycling, I know that within the CPA there is a consensus that whenever mechanical recycling is possible, then that should be the preferred option. And chemical recycling should kick in when mechanical recycling is not possible for any sort of reason, be it a technical reason or the quality of the output or economic reasons. So the bottom line is chemical recycling should compete with not with mechanical recycling, but rather with incineration or landfill. That's the field of competition for chemical recycling.
Excellent, and I think
I know that you are making a lot of progress. The polystyrene market is making a lot of progress on the technologies for chemical recycling, and we think in the Commission it's very promising, and we are looking forward to seeing the result of it, being possibly having this technology enabling your ability to make a pledge for recycled plastics. We think it would help enormously to have a successful ending for the CPA. So we are really looking forward to that.
Thank you so much, Paolo. And specifically with regards to your comment that chemical recycling should at least compete with incineration, I think that means that we are looking forward to the LCA results that Regino has given us first insights on today, where we then also will compare depolymerization with incineration and look forward for favorable results here as well. Thank you so much. Thank you for giving us your perspective and engaging here with us in the value chain in this session. Great. And with that, just in keeping with the time, before we move on to the Q&A, I would like to quickly make an announcement on further events, on a new series of online events that we are launching for 2021. And in these very topically focused events, which go, for example, on the LCA, but also what Jens touched upon, advances in the recycling of ABS, so going beyond polystyrene for food contact, and then also to the third technology that we look towards having a deep dive more into the dissolution recycling technology of polystyrene. So the dates are not announced yet, but all of those who are subscribed to our newsletter or have subscribed to our news items via registering to this call today will receive the invites for that. And with this, I would like to turn to the Q&A and give the floor to our audience and to the questions that you have raised. And it leads me, first of all, to say a big thank you for our speakers, their presentations and analysis. And now let's have a look. We have received already quite a few questions in advance and throughout the last hour. So I would like to ask our speakers to turn on their cameras as I pull up questions that have come towards us. So the first question that I have here is, what volume of RPS will be available in 21-22 in Europe? I'd like to put this question forward to Jens, please.
Thanks, Chrissy. And yeah, that's indeed, I would say, Yeah, in my opinion, it's a key question. So it's a great question, and I'm happy it comes right in the beginning after such presentations we have seen. It's a key question. It's also a burning topic, not only for our value chain, but in general. And I think we have already given here confidence what we do and where we drive at. So basically, it's first of all not serious now throwing numbers, looking at the time span. But I like to conclude on that question with, let's say, the volumes, with another call for more confidence. And first and foremost, you out in the market, please pull, pull, pull. We have heard today this creates a lot of effect, market pull, market value, and this basically also gives the confidence to answer this question soon also with volumes. Yeah, I think we have heard recycled PS feedstock, so PS feedstock waste is sufficiently available if we do the right things at the right time. It has highest SCS priority, and even knowing it's more challenging in light of our food contact ambition, this is first on the agenda. We have heard today again, and I think we can somewhat tick in the box, the recycling capacities are there, and also the converters are ready to kick off. So this is really something we can tick and then say, okay, this is good. From Hermann's presentation also, I would conclude that the high-speed works and collection sorting is already delivering great results. Just to conclude on that, number one, PS is out there. I have said that as well in the mixed plastics waste. It's collected even to the extent and sorted also, but not going to the recycling process. Again, I would say this is positive. Looking at the yellow bin and other areas where we really can say we just have to connect the dots here to say so in order also to increase and bring it back into the stream. And just to have some insights here, we are in intense discussion with EPRs and PROs. Core countries are here: France, Germany, Italy, Belgium. We make great progress getting in the guidance, in the listing, in the collection, in the sorting area. So this is another striking argument. So I think for the other part of the question, the sorting capacities, mixed plastics waste, they can sort all the polymers, and there I'm very confident that this high market pull, the high market value we are generating here also will be a strong contributor that we maybe start small in 21, but we will scale fast.
Excellent, thank you. And I have a follow-up question on that. Can we use recycled polystyrene right away as middle layer in an ABA structure for food contact applications? So, or does that require full food contact approval first to be used also as a middle layer? I give that question to Hermann first, and maybe then Iain, if you would like to join in.
Well, Chrissy, it is we have to understand here that if we talk about ABA, the intention is definitely to use the same quality of polymer as what we have, as what we submit to the EFSA petition. So for even direct food contact. So there's no matter that we would accept any lower quality. And so this means that the ABA structure allows more, let's say, to overcome an administrative delay than a technical thing, because this is of exactly the same quality.
Excellent.
And if I may add, I think here we also have to look at the regulations in place. The Commission's regulation, specifically 10 from 2010, says that it permits an ABA use as long as it's within the safe limits of migration. That means that the migration is within the, let's say, the food safety limits that are established. Those limits today are 10 milligrams per decimeter squared. What we can say from our side is that the tests that have been performed are well within those limits, with a range between 0.5 to 1.5. So, you know, not even consuming 15% of the established limits. So well within the limits, and whilst the EFSA approval is going on, as far as if we're looking at from a legal legislation point of view, we're safe and it can be used.
Wonderful, good. The next question goes into the same direction here. How fast do you expect to get official recognition of food contact by EFSA and the Commission? Jens, can I direct this question to you?
Chrissy, how come that I get all the easy challenging questions here? But yeah, to answer that one, and it's again a bit of a tricky one, this fast and EFSA food contact and approvals. Basically, and I think you know, but like to put this first, EFSA petition opinion, it's a process, and it's an institutional process within the European Commission. So looking then taking this up from EFSA, it's not in our hands, yeah, and therefore it doesn't help that much if I would say the timing for that is in a magnitude of 6 to 12 months, but this is what it is, yeah. What I think is very important here in order to be not patient, but of course to move ahead and don't look only at the EFSA process, which is coming, and of course it's great once we have it, but it's very important that we somewhat do this, what we had heard also the ABA, let's say, progress and using recycled polystyrene already in its final, let's say, quality in the middle layer and the B layer. Yeah, I think this is very important that we can go ahead, that we have this quality in the middle layer, the final quality already. As I said, it might be even more than one EFSA process, maybe 2 or 3 at the end. However, the final material in the middle layer makes us readily available starting and going ahead once we have the first EFSA position on that and the approval by the Commission. And then, of course, we can even go to mono and leave the ABA behind. I think this is a very important point here. So my call is here on this question also, we don't have to wait, and we can be faster and parallel to the EFSA process, go ahead. And I think Paolo mentions this preferential treatment of food contact recycling, also by the Commission within the CPA and the high technology readiness levels we have heard today, just again, pull. And I cannot resist to say one thing on the presentation of Paolo, because it was mentioned priority products, and it's good news also here, I think, to add that PS, EPS, XPS and the list also of priority products and the working groups, and we are working here together with CPA strongly in this direction.
Excellent, wonderful. So with regards to the timing, we've received a lot of questions, trying to group them a little bit so that they go into the same topic areas. Let's give a couple of more minutes to that. I have here the question of how big is the difference of yogurt pots made from mechanically recycled polystyrene to those made from virgin polystyrene? Now, this is a question that I would like to put over to our converters who handled this. Anabela, would you like to give it a go?
Yes, Jens, I have the easy answers because for us, we got the easy answers. Like I already said, we have the same product, the same cup, the same multi-pack. The only thing that is required is that brand owners let them consumers know that this is done by recycled materials, sustainable solutions, because the pack itself is exactly the same.
Excellent. So we can't notice that. Fantastic. Then the next question goes to how many times can a yogurt cup be mechanically recycled and when does the quality decrease? Over to Herman. Go ahead.
Yes. So polystyrene is the polymer that suffers the least from processing or from reprocessing or from recycling. And so basically, even after you process or you extrude polystyrene 20 times, there is hardly some degradation to see. So there is no, from the polymer perspective, there is no limitation on it. I would say virtually no. So,
excellent. I see Anabela and Iain nodding already. Herman, Norbert, let me put this question to you. Is there any difference with depolymerization?
Depolymerization, I would say you create a novel state each time you depolymerize. That means that, let me say like this, we of course have a certain yield, as I mentioned in my talk. That means that we simply have to access, like in every chemical process. But given the fact that we have to observe yields and byproduct and need to clean up the styrene, we can do that 1,000,000 times or 1,000,000,000,000 times. You can count whatever you want. It will always be returned to the same molecule with the same purity if you use the same purification unit, like a distillation with certain amount of theoretical plates, to be a bit more technical, right? So this is literally infinite.
Infinite recycling. Excellent. Thank you. So I have here a question from that is regarding the first depolymerization plant will be operational in 2023. How fast will you be able to scale up capacities from that? Norbert, a typical question that would go for you.
Yeah, if I had a crystal ball, I would give you an exact date. But what we can say is that first of all, can confirm what you have said. The 2023 that was announced, that is the target, and then echoing what Jens mentioned, create demand, and that is the dynamic where a fast scale up will happen. Yeah. I mean, this is as usual. Supply and demand is a balance, and as we have heard today, polystyrene is truly unique. I think we cannot say that often enough. And with that, let's say, game changer in mind, I count on a pretty fast scale up, because there's nothing that should hinder us. So if customers want it, I do not see a technical reason, a fundamental technical reason that should hinder us from scaling up as rapidly as the customers want. But to give an exact figure, Chrissy, I hope you understand and accept that this all depends on the customer demand. But I'm very optimistic, especially after today's talk, that this will ramp up very quickly.
Okay, thank you for that.
Yes, I think that even faster you will see investment decisions being taken on mechanical recycling. And these recycling technologies, actually, they are complementary. It's not because you have one that you should limit it to one. And many parties have been waiting for success in food contact, technically proven. And the fact that we are here is going to accelerate several projects at several places at the same time. We're convinced about that.
Wonderful. Let's stay on depolymerization. I have here another question that comes along on LCA study on depolymerization. Now, what we've seen from Regino is that this is still work in progress. And the question refers to another study that has been recently made, an LCA study called Resolver, that has recently published results of an improved environmental footprint of 37 to 50% compared to the virgin material. Question to you, Regino, do these results look reasonable to you?
I will take up this question. Yeah. So I will try to answer this question quite quickly. Like the Resolve project, as I'm aware of, was a public funded project, and it dealt with the pyrolysis of polystyrene back to styrene monomer. And there, during the project, I think there was also an LCA study conducted. And yeah, as I said, there were quite promising results. And the main difference we have here to the study we are doing is that these results were based on data from a laboratory scale process. And yeah, we are now working together with Agilix, and we get there really data from more an industrial scale plant. And these plants in industrial scale are, of course, a lot more efficient than a laboratory scale process. And so I would presume that the results we get out of that LCA when it is finished are even better compared to the results we have from the Resolvi project.
Question on the PS unique benefits across the life cycle. We understand that there's a huge importance of retailers and brand owners. Where does SCS stand on the inclusion of these stakeholders? I guess there are multiple ways of interpreting this question. Jens, I put this one forward to you.
Yeah, Chrissy, I don't repeat myself now on the questions, but I just want to say it's a great question, and there's a famous saying that tells the fact that you do not see does not mean it's not there. Yeah, so everyone maybe who thinks also that the membership of SCS or somewhat more visibility, I think we very well know and have seen the graphic also on the circular loop. And I come back to the converters testimonials. Of course, brand owners, they are also to the extent customers, main customers by the converters. And if you have this great news at converters and the product and the development and the economics and never change this winning team or even put on the next level, I want to just say, of course, there's a lot of activity also involving SCS because the brand owners, they are an integral part of our value chain. And of course, we have to keep the pace also. If you talk about this market pull and the availability of RPS to the market, of course, the brand owners are fully included. And by the way, it's the same then for the next step, which are the retailers, to refer to your question. So we regret a bit that we cannot disclose more, but there's a lot of activity going on positively, also not surprisingly, because we have this pull and the product getting ready. And if you look, for instance, all around the press releases, the pictures, whatever you see more or less on a weekly base on the yogurt pot, even being then carrying labels by the converter, this is going to change. And of course, the yogurt pot inclusion and all this progress could not be made with the inclusion of the brand owners and again also with the retailers. So the inclusion work is highly progressing, and once we're ready, you will see that we have the brand owners included. And I'm also pretty confident today in our webinar here, there are quite a number outside and listening on the progress and will appreciate what are we doing here.
Thank you. And just conscious of timing, I accept here one more question which just fits in nicely, which actually comes from a French brand owner from the dairy sector. And here, that's what the question reads. What can food industrials do to help PS recycling technologies to progress? What can food industrials do to help PS recycling technologies to progress? So that looks for me like already a testament of a market pull that I'm reading. I'd like to put that one also to you, Jens, and with that then close and wrap up this Q&A.
Yeah. Yeah, again, that's a great question. I really see this is in this webinar coming a lot of great questions, and of course, this also is a one not easy to answer in really a few moments here, but somewhat, of course, have certain organizations, for instance, reconsidered PS? Yes, indeed, and quite substantially, and it's progressing further. It was mentioned here, our discussion also with the EPR and PROs, whom I like to include in this question also, and recyclers organizations, because there's a step change in a way that recycling of polystyrene comes up top of the agenda. And again, looking then as associations point of view or organizations, like we have them not mentioning them, but we know we have them in France and in Germany, in Italy. Of course, this pull is very well progressing. Yeah, and therefore I think it stands the same what we discussed here. The majority of these food organizations want recycled polystyrene. They are waiting. The market wants, and they have to respond to that. The solutions are ready, as we have seen, and also the testing. And again, also here, I would say we cannot disclose more details, but I think if you go to the press or Google and look a bit what's, for instance, going on, I like to just mention France here, and those names, which of course driving here circularity, and you look at the polystyrene, you will really see the progress we are making here. And again, on the pull and on the inclusion, of course, all the others which are not yet with us, those organizations have a huge impact, and we just can have a call for action also here to contribute and to support and to drive the RPS development further forward. This would be my answer, Chrissy.
Chris, I would like to add something very quick, may I? It's a very good question. I will take it in a very practical way. I think all the industry did everything is basically done. We just need to have quickly to have the EFSA approval that we are very positive that we have. Then we have the challenge. We have to balance the demand and supply of RPS. We know, like the brand owner from France was asking, we know that majority of brand owners are waiting for RPS. We are completely committed to it. And I and the converters that are with me and all the supply chain will ask to have a little bit more patience, because the waiting line that we still have is going to be compensated for the fact of we don't need any changes and no investment. And I think this will be the best answer for also to add to our brand owners. Thank you.
If I may add one extra thing, as I'm chairing the feedstock part, brand owners are all members of the EPR organizations who decide about the collection and the sorting. So they can play a role in these organizations to make sure that all PS packaging, not only the rigid but also the foam, that they are all getting accepted in the collection and that they are all sorted out as feedstock. Now that they know that there will be a positive outlet for this waste. That is certainly a very good contribution they can make.
Thank you so much. I would love to continue going on, and we still have a lot of appetite also here from the audience. In view of this timing that we have here, I would like to close the Q&A. Thank you for that. And I would like to make a quick announcement before we part. If we could bring up one last slide. And this goes out to all of you. First of all, for everybody who would like to watch this event again, or if you would like to share this event with any colleagues who may have missed it or who are in a different time zone, there will be a replay available. Everybody who has signed up to receive further news items for SCS, you will receive it automatically. Other than that, it will also be placed on our website. And the same goes for the broadcast series that we've already announced, and an easy way to do so to get all the news items from SCS is to sign up via our newsletter. And with that, I would like to close the event for today. I would like to thank our fabulous speakers here that we had today. I'd like to thank Plastic Packaging Europe for hosting this event, Kane specifically, who had been helping us overcoming all technical issues in the background, and to all of you for being such a fantastic and interested audience. Thank you so much. Have a good day. Bye-bye.
Bye.
Thank you.
Bye-bye. Thank you, Chris.
Thank you, everybody. Goodbye.
Bye-bye.
Thank you, Chrissy. Thank you all.
Bye.
Till soon.